Okay, 5.3 is multiplying polynomials. The main thing we're going to talk about, and the main um, operation we're going to use is the distributive property. So sometimes you're going to have a monomial times a binomial. Sometimes we have a monomial times a binomial times binomial. So there's different operations that you're going to have to do, but you're all going to do it the same way, and that's by using distributive property. So in this situation, we have a monomial, one term, being multiplied into a binomial, two terms. So what you're going to do is you're going to take that first term, and it's a negative 4a, and that has to be multiplied not only to the a, but it also has to be multiplied to the 3. So just do one operation at a time. Negative 4, and this would be really a 1a. So negative 4 times 1 would give me negative 4. And then a times a would give me a squared. Then I'm taking the negative 4a, I'm multiplying it by 3. So all I'm doing is negative 4 times 3, which would give me a negative 12. And then we just keep the a. Again, it's pretty much reviewing. You got to make sure you know the properties of multiplying monomials, because that's really all you're doing. If you're really doing 1 times 1, okay, but you're going to repeat that various times. So let's look at another example. It's the same thing. We have a one term that's being multiplied into a 3-term polynomial, and we call a 3-term polynomial a trinomial. We're taking a monomial, multiplying it into a tri. You're going to do the same thing we did on the first example. We got to multiply it 3 different places. So again, you're doing monomial 1 times 1, but you're doing it 3 times. Okay? 5x times 2x squared, you do 5 times 2 first, get your 10. And then x times x squared, remember this x is a 1, so we're going to get x to the 3rd. 1 plus 2 would give me the 3. You just got to watch these signs. So again, on this one, you're doing 5x times negative 4x. What's 5 times negative 4? That'll give me a negative 20. And then x times x gives me x squared. Remember, each of these exponents are 1, so it's 1 plus 1 would give me the 2. Then I'm doing 5x times 3. 5x times 3 would just give me 15x. And just make sure if I have like terms, which I don't, this is x to the 3rd, x squared, x, I can't add these together, so they would just stay just as it is. Now this is really the most common ways that we multiply polynomials, and that's a binomial times a binomial. Okay, 2 terms into 2 terms. Some of you might have learned the FOIL method, first times first, outside times outside, inside times inside, last times last. I don't do that. What I do in the way I teach it is you take this first term, which in this case, you look at your first term in your first binomial. In this case, we're taking the x. And I'm going to take the x and I'm going to multiply it to both terms into the binomial. So in other words, I'm almost doing it like this problem above to start out. I'm just taking it, that first term, and multiplying it into both of these terms. So x times x, what does that give me? That gives me x squared. And then x times 2 would give me 2x. All right, so that's my first part of the problem. Take that first term, distribute it into both terms in the following binomial. Now we're going to go to the next term, which in this case is plus 7. And I'm going to multiply that into both of those terms. So I'm going 7 times x, which would give me a 7x plus 7x. And then a positive 7 times a positive 2 would give me a plus 14. Now, if you do it this way, which I strongly encourage you to do, using, again, it's not necessarily FOIL, it's just taking the first term, distributing it, taking the second term, distributing it. What will happen is you will notice the 2 middle terms are almost always going to be your like terms. So I can combine those two. The x squared can't go to anything, that 14 can't go to anything. So we're going to rewrite this as x squared, 2x plus 7x would give me 9x, plus 14. Okay, so you take your two terms, add them together. They're two like terms in the middle. And once you do that, now we have a trinomial that are three unlike terms. All right, and we're going to just do a few more examples of binomials times binomials. 2x squared plus 3 times 6x squared plus 7. Again, first term, in this case, it's a 2x squared, and we're going to distribute it into both terms of the second binomial. 2x squared times 6. Okay, first we do 2 times 6. That'll give me 12. And then x squared and x squared, how many x's altogether? We add 2 and 2, and we get 4. So that's 6 times 2 is 12. X squared times x squared gives me x to the 4th. 2x squared now times a positive 7 is going to give me 14x squared. Okay, I'm ready to move on to my second part. Second term in the first binomial is 3. So we're going to take 3, multiply it by 6x squared. That'll give me 18x squared. And then we're doing 3 times 7, which would give me 21. Again, what you'll notice, middle terms are my like terms. And in this case, I'm doing 14, positive 14 times positive 18, which would give me 32x squared. The rest of the values just move down. Again, can't add these together. This is x to the 4th, this is x squared, this is my constant. I can only add them together if their exponents are the same, and this one doesn't even have an x. All right, we're going to kind of continue with that. Binomial times a binomial. Now, if you look at this one, number 5, you have 5y plus 3 squared. Okay, and what we're going to do is we're going to expand that out first. And what does that mean? That means 5y plus 3 times 5y plus 3. And once we expand it out, well, now, again, we can follow our distributive property. First term times both terms in the second term. 5y times 5y is 25, and it's y squared, because it's y times y. 5y times 3 gives me 15y. To that plus 3 now. And we're going to multiply that to both terms. 3 times 5y would give me, again, 15y. And then 3 times 3 gives me 9. Again, what we notice is after we do that, we got to combine our like terms. It'll be those two terms in the middle in most cases. 15 plus 15 would give me 30y. And again, that would be your answer. We cannot combine these anymore. The only like terms were the 15y's and the 15y's. I want to do one with some negatives because you just got to be careful with some of the negatives. Start the same way. First term is going to be distributed to both terms. And just remember, when I'm doing this second term, I'm multiplying it by a negative 6. So I got a 4x here and I got a negative 6 here. To start out, 3x times 4x would give me 12x squared. Then 3x times negative 6 would give me negative 18x. And again, now when I move to this second term, what am I multiplying into everything? Negative 4. So I'm doing a negative 4 times 4x and a negative 4 times a negative 6x. Negative 4 times 4 gives me a negative 16x. Negative and a negative. Multiplying a negative 4 times a negative 6 would give me a positive 24. Again, before we finish, we're looking for our like terms. And the like terms are in the middle. A negative 18 take away 16. gives me a negative 34x. The rest just gets moved down. And that would be your answers. So just so you guys know, if you haven't seen a pattern, anytime you're doing binomial times a binomial, two terms times two terms, your answer in the most part is going to be a trinomial. There are some special circumstances where that middle term will cancel out, but in general, you're going to have three terms. Now let's talk about what do we do when we have a binomial that's being multiplied into trinomial. Okay, so we have two terms multiplied into three terms. So what's going to happen is just going to require us to do one additional multiplication. Okay, but again, I start the same way. First term is distributed. Normally we just would do it two places. Well, now we got to distribute it all the way to everything in there. All right, and then when we get to the negative 6, we're going to do the same thing. We're going to distribute it all three places. I tend to write this one just a little bit different after the first time I go through, because I would like to write my like terms instead of kind of doing them horizontally. If I can, I'm going to kind of do them vertically, and I'll show you what I mean. So let's start with the x, and we're going to follow these arrows up here. X times x squared would give me x to the third. X times, and again, it's a negative 4x. X times a negative 4x. Remember, there's an imaginary, some of these are imaginary ones here. Remember, the exponent there is 1 as well. But 1x times negative 4x would give me a negative 4x squared. We have two x's, x times x. And then 1x times a positive 3 would give me a plus 3x. All right, so at this point, when we move to the negative 6, we're going to follow these arrows on the bottom. The only thing is normally I would just keep writing on the side. I'm going to try to write my like terms underneath each other if I can. So in other words, if I do negative 6 times a 1x squared, this is going to give me negative 6x squared, right? So I'm going to write it under its like term. I already have an x squared here. So I'm going to start negative 6x squared right underneath its like term. And in the most part, what's going to happen is as I keep going, the next like term will be here, and then I'll have my constant out here. So negative 6 times a negative 4x, negative and a negative is going to give me a positive. 6 times 4 is 24, and then I have the x on there as well. And then my last one, negative 6 times a positive 3 would give me a negative 18. And I just got to add my like terms. Well, there's nothing that's going to go with the x to the third. There's nothing that's going to go with the constant of negative 18, but I do have like terms here. These I have to add. Negative 4x squared minus 6x squared gives me a negative 10x squared. And then 3 plus 24 gives me a plus 27x. Again, you always want to check, are any of these like terms? This is x to the third, x squared, x, and negative 18. They are not. Remember, same variable, which they have the same variable. The reason why I can't add these together, exponents are different. This one's 3, this one's 2, this exponent is actually 1. And then we have our constant here as well. Let's look at another one. This is actually 11 from your homework. So what's happening here is all these three terms are being multiplied together. So remember when we had, this was a binomial times a tri, binomial times binomial. What we have is monomial times a monomial times a monomial. Three single terms being multiplied together. And really, the way you do that is kind of the easiest way is you just multiply your coefficients first. So 5 times negative 4 is a negative 20. And then negative 20 times 3 would give me a negative 60. So that's the first part. Again, you're multiplying x's together. We're not adding them. Remember, when we add them, there are different terms. But when we multiply them, the rule is they have the same base. You keep the base, and you're adding exponents. This exponent here we know is a 1. So I'm going 1 plus 3 is 4. 4 plus 4 would give me 8. So that would be negative 60 x squared. And the final example, this example, we have a binomial with a negative and a binomial with a positive. Just kind of make sure we have examples every time. So let's take my first term, multiply it to both terms in the second. 4x times 6x gives me 24x squared. 4x times 1 gives me 4x. Move on to my second term. Again, it's a negative 11. That's being distributed. So negative 11 times 6x gives me a negative 66x. Negative 11 times 1 will give me a negative 11. So my like terms, again, are in the middle. We'll just move the 24x squared down. Minus 11 down as well. And this is a positive and a negative, and we're adding these together. So we're going to subtract these. 66 minus 4 would give me a negative 62. Make sure he's right. Yep. Okay, so a negative 62x. Again, check that our terms, that we can't combine them anymore together. And again, once you do that, you are done. So that is 5.3 multiplying polynomials. Again, probably most important thing is these binomial times the binomial, that we understand what we're doing on those.